Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to understand and or statements of inequalities and how to graph all kinds of inequalities on the real number line. How are we learning it? Through the Inequalities Train Part 1 notes and the Inequalities Train Part 1 assignment. When can we use this information? To determine which scores you can receive on your final exam that will allow you to pass the course. How do you know you learned it? By getting a score of 4 on the Inequalities Train Part 1 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Inequalities Train Part 1 notes, and then I'll give you time to complete the Inequalities Train Part 1 assignment on Google Slides. Once you've completed your assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Linear Inequalities Study Guide and any incomplete assignments that you may have. Let's take a look now at the Inequalities Train Part 1 notes. The notes begin with the learning goals and success criteria. Now, what is an inequality? An inequality can be of any of these forms. This symbol, this one here. So this one looks like an arrow going this direction, an arrow going this direction. And then we have the arrows with the little bars underneath. And what do these mean? Well, this first symbol means less than. So we have this symbol meaning less than. This one then means greater than. This one means less than again, right? Because that's this arrow. And the bar means or equal to. So this is less than or equal to. And this one, this arrow here, meant greater than. And the bar means or equal to, so it's greater than or equal to. So those are the different inequalities. Now, how can we remember the signs? The easiest way I remember the signs is Pac-Man. So we have Pac-Man here. And Pac-Man's rule is Pac-Man always eats the bigger number. So if you notice, Pac-Man's mouth forms that arrow shape that we just talked about. So it forms the symbol. So if Pac-Man is always eating the bigger number, then we can recognize the way that we can state the symbols. For instance, we have 3 and then this symbol and 4. Well, Pac-Man eats the bigger number, so if I draw Pac-Man on there, I can see that his mouth is eating this side here, which means this is the bigger number. So this number is greater. Well, we always read it from left to right though. So that means if this number is greater, this number's got to be smaller. So we would say 3 is less than 4. Now here we have 6 on this side, 2 on this side. And if we draw Pac-Man in, there's Pac-Man. Pac-Man, again, always eats the bigger number. So we have 6 being bigger. And we read it from left to right, so we say 6 is bigger than 2 or 6 is greater than 2. So that's one way we can remember the signs. Now, plotting inequalities on a number line. When plotting inequalities on a number line, you must follow specific rules. First of all, for less than or greater than symbols, we use an open circle. For less than or equal to or greater than or equal to, we use a closed circle. And then we shade in the direction of the inequality. So how do we remember the circles? The way we remember it is this. Every inequality gets a circle. And if they add more to the inequality, we add more to the inequality. What does that mean? Well, this is a basic inequality symbol. This is x is less than 4. Well, this is a basic one, so we start with a circle. If they don't add anything extra, meaning they don't add the bar underneath, then we leave it as it is and leave it as an open circle. Now, if they add something to it, for instance, this one says x is greater than or equal to 2. If they add the bar underneath, so if they add something extra, we add to it as well and shade the circle in. So now, we know that if there's no bar, we leave it as an open circle. if there is a bar, if they add something extra, we add something extra also and fill it in. So let's look at how we plot these inequalities on a number line. Well, we have x is greater than -3. So first of all, we're going to find -3, which is here, and we're going to decide what kind of circle we need to use. Well, we start with an open circle, and we decide whether we need to shade it in or not. Well, they didn't add anything extra, no bar, so we don't add anything extra either, and we leave it as an open circle. Then we need to shade the values that for x that apply. Well, it says x is greater than -3. So where are all the x's that are bigger? Well, -2 is bigger than -3, -1 is bigger than -3, 0 is bigger than -3, so it's all the numbers on this side. So we would go ahead and shade it with an arrow going this direction, meaning that all of these numbers over here are bigger than -3. Let's look at another example. We have x is less than or equal to 3. So now we're going to go ahead, we would start with an open circle here at 3. And we decide, did they add anything extra? Well, they added the bar underneath, so we will too, and we will come up with a closed circle. Now from there, we're looking at all the x's smaller than 3, right? Because Pac-Man's eating 3, so that means 3 is bigger than all the x's. Well, where are all the x's smaller than 3? Well, they're smaller on this side here, so we would shade in this direction. Now, what is a compound inequality? A compound inequality is two or more inequalities joined together by and or. And what does that look like? It looks like this. 2 is less than or equal to x is less than 6. So that means, what that really means is x is somewhere between 2 and 6. And because it has the or equal to on this side, it can include 2, but it can't include 6. So it's somewhere between them. So how do we do this on the number line? Well, we're going to do the first part. Well, we see that we need to plot a point at -3. So we're going to start with an open circle. And we look at the symbol here. They didn't add anything extra, so we won't either. So we'll leave it at -3. Then we'll go to this one. We know we're going to have an open circle at 4 and check to see if they added anything extra. They didn't add anything extra, so we're going to leave it just like that. And we can see here that x is between those two numbers. So I'm going to shade everything between those two numbers here. And that's my compound inequality on the number line. Let's take a look at another example now. We have -2 is less than or equal to x is less than 5. So we know we're going to have a point at -2. And they did add something extra, so we will too. So it's going to be a closed circle here at -2. And we're going to have a point here at y. They didn't add anything extra, so it's going to be an open circle. And based on our compound inequality, we see that x is between those two numbers, so we're just going to shade in between. Now let's talk about and statements. So and statements imply that both inequalities must be satisfied simultaneously. So for instance, x is greater than 4 and it's less than 6. So we know that tells us it has to be between 4 and 6. So this is an example of an and statement. And statements should always be shaded between the 2 points, just like this. So this is an example of an and statement. Now let's look at or statements. Or statements imply that one or the other inequality must be satisfied, but not necessarily both. So in this case we have x is less than -2 or x is greater than 5. Well, whenever we have an or statement, they should be going in different directions. So we have x is less than 2, which means it can go this direction from -2, or it can go to the right from 5. So that's an or statement. There's a video here that shows you how to check your work when dealing with inequalities on a number line using Symbolab. So go ahead and watch that video. Let's take a look now at how we can use Symbolab to check our work when dealing with plotting inequalities on the real number line. So we're going to go ahead and place in our box what we want to plot. So let's say we have x is greater than or equal to 3. So we can go ahead and put it in like that, and we go ahead and click go. And notice it says x is greater than or equal to 3, which is what we want. And if we scroll down, it'll solve it for us if it wasn't already solved for. But if we continue to scroll down, it'll plot this on the number line. So it gives us a point here at 3. It's closed in and then shaded to the right. Now we could do this in a number of ways. We could also do a compound inequality. So let's say it was 3 is less than x is less than or equal to 6. We go ahead and click go. It pops up with our solution here. If we scroll down to the number line, now we have an open circle at 3 and a closed circle at 6 and shaded between. So this is how you can use Symbol Lab to check your work when plotting inequalities on the real number line. Let's take a look now at the Inequalities Train Part I assignment. Our assignment begins with learning goals and success criteria. If we scroll down, it tells us to go back to Google Classroom and click on the link that has your name listed. And when we do that, it should take you to a page that looks like this. If you click on the third slide, it takes us to the assignment. Now on this assignment, we have a start here and an end here and a bunch of cards that go around. There's a few that have been placed there for you so that you can see where you're at. Now, what we're going to do is we can't really read these, so we're going to go ahead and go to where it says here with this zoom. I'm going to click on that, and I want to go ahead and zoom to 100%. Now I can kind of see what I'm doing. So the first one says x is greater than or equal to 2 and x is less than negative 3. So I know it's going to be less than negative 3. And it's going to be greater than or equal to 2. So it's going to be both. So are there any numbers that are in common there? Well, there should be no numbers that are bigger than 2 and smaller than negative 3. So there is no solution. So we're going to find the one that has a no solution on it. So we're going to find the one that has a no solution on it, which is this one here. And we're just going to click on it and drag it over here. So there's my first card. Now the second one says x is greater than or equal to 2 or x is smaller than negative 3. So we should have something smaller than negative 3 and something larger than 2. So I need one that's going in two different directions. So I'm looking here, I see this one has smaller than negative 3 and this one's greater than 2. So we want it to include 2 and not include 3, which is this one here. So we're going to click on it and drag it over. And we're going to go ahead and place it here. Now this one should say the same thing as this. So we'll go ahead and check that. And we'll continue to answer all these questions until we fill out our whole train and get to the end. Once you get to the end, we'll go back to our Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.